All right. May I invite you to open a file that I posted. So nag-post ako ngayon sa ano natin, sa model natin. So notice guys, unit 3 na to, no? So may mga files dito, 1 or 2 files na hindi ko pa nalalagay kasi nga which was supposed to be our discussion today, but since it got corrupted, I decided to move on first to unit 3 para hindi masayang oras natin. So may 4 files ako dito, no? Number 1 is a binary CSV. So this is a data file in comma-separated value. And then this is what we're going to use in logistic regression and diagnostics in RMD file. Tapos, depende sa time natin later on, kung umabot na tayo sa time, I'd like us to discuss itong decision tree, which is a machine learning tool. So notice guys, itong subject natin to combination na ng regression, time series, at saka insights ng machine learning. Kasi yun na yung bago ngayon talaga, yun na yung ginagamit ngayon. So we would like to make use of, siguro wala naman kayong subject pa na nagtakal kayo ng machine learning, di ba? Right?
Wala pa, sir. Sir, question.
Yes, yes.
Yung sa thesis, kung may na-advise kayo, yung R yung mostly ginagamit to finish yung thesis?
Depende sa ano. Kasi yung iba kasi, paano kung hindi nila alam yung R? Siyempre, hindi sila mag-R. So yung iba ang ginagamit, pag time series e-views, no? Minsan stata, depende kasi sa availability ng ano mo, depende sa, sabi natin, sa skill set mo, no? Or sa skill set, kung kunyari may nagpapatulong ka, depende rin sa skill set ng tutulong. But usually pag statistician or computer scientist or data analyst, either Python or R, no? And I'm happy that you have hopefully before the term ends or by the time the term ends, medyo sabihin natin na ano yung knowledge sa R is already quite comprehensive, and kahit on your own makakaano na kayo ng mga models, pag kunyari magre-research kayo tapos hahanap kayo ng mga sample ng mga models, let's say on vector autoregression. So pwede niyo i-Google tapos vector autoregression in R. So pag tinignan niyo guys, hindi na kayo maliligaw kasi alam niyo nang basahin. You know how to read, you know how to interpret. So yung ano na lang, yung pagko-code, then you can be guided by those who have done that modeling before. And ang kagandahan ngayon guys, napakarami ng information, napakarami na ng pwede natin maging source kasi R is really a very robust language and ang daming gumagawa ng modeling sa R. In fact, more than Python. Tapos ang dami nagko-contribute. Okay? So you're in good hands, guys. Thank you for that question, Richard. So,
thank you, sir.
Ang ano ko sa inyo, ang friendly advice, ituloy niyo yung pag-aralan talaga yung R. Tapos angkinin niyo, and you'll be glad you did. Okay? All right. So kindly open, guys, yung logistic regression diagnostics, no? Oh, wait, naka-share ba ako ng screen? Hindi yata, ano? Okay, so hindi.
Not yet, sir.
Okay. All right. Ito guys sa canvas natin. So I uploaded 4 files. I'm not sure if we can reach up to 3.4, no? But definitely we'll try to finish 3.1, and yung 3.1 yung file kasi yan, yung model natin yung 3.2. Now, wala pa yung multinomial dito. Yun ang I don't know kung mag-multinomial na kagad tayo or balikan na lang natin yung regression, yung na-corrupt ko na file. Okay, so we will go back there first and then tuloy natin tong multinomial naman. And then other forms of regression like ridge, lasso regression, mga special types of regression to which cater to certain nuances of your data and your data structure. Okay, so kindly download guys si binary at saka pakibuksan si Logistic and Regression and Diagnostics. So let me open that. Okay, close ko lang. Okay. And please tell me if you have opened it.
Yes, sir.
Okay, how about the rest? Ina, Samia, Ina?
Open na, sir.
Okay, good. All right, so kindly download, guys. Either gamitin nyo yung import dataset or you can use in advantage, guys, ng setting the working directory is that if you set the working directory, pinari isa-set ko dito. Although nakaset na kasi dito yun eh. Isa-set ko lang siya dito. Run ko. Okay. Tapos pag nakaset na dyan, guys, I can just use the name of the file in order to load it. So, okay, naka-ano na siya, nakaset na siya dyan. Okay, nakaset na siya dyan, guys. And then, take a look at this, no? I'm going to create an object called dot, short for data, and then read that CSV, and then just put the name of the file. Okay, so make sure that you save your file, your data file, in the directory that you want, in the working directory that you want. I assume that you created a working directory dyan sa ano nyo, sa desktop, and you can save the binary CSV file there. Okay, so I'll just run this. Okay, so dito na siya, no? Yan. So downloaded na si that, nasa object na siya. So I'll wait for you guys. If not, guys, you can still use the old reliable import dataset. Pwede naman to. Either Excel file siya o base text. So text naman siya. So you can use it from text and base R. Okay, so once you have your that object ready, kindly inform me so that I can continue. Okay, thank you, Ina. Let's wait for the others. If you're done, kindly unmute na lang yung sarili nyo, ano, para so that I will not need to look at the chat. Okay, I think you're saying done. Okay. Sino pa? Chard, okay ka na?
I-import pa, sir. Nag-error lang.
Sige, okay lang. So we'll wait for you. Huwag tayo mag-run na ano, may naiiwan sa inyo. Sige lang, take your time.
Sir.
Okay na?
Last try.
Take your time, Chard. Huwag mong i-ano, baka...
Yeah.
Okay na?
Ito, sir. Wait lang. Try ko na.
Sige lang.
Sorry.
By the way, I'll make you all co-host so that when you share, kunyari may question kayo. For the others, pwede nyo i-view yung ano natin, ano, yung once you have uploaded it. Let's view our data. I-view nyo na lang. Kahit dito na lang sa console. Ang bagal mag-run ito. View lang, ang tagal.
Pero ko yung share ko yung screen ko.
I-share mo nga yung ano mo. Richard, ba't kaya nagkakaano?
Sorry.
Sige nga, share mo nga. Stop share ako. Share mo yung screen mo.
Nakita niya, sir.
Yeah, oo. Sige.
Ay,
Andiyan na yung dot mo. Andiyan na.
sorry.
Andiyan sa baba yung object.
Sir, nakikita niyo yung screen, yung folder or yung R Studio?
RStudio.
Okay. Ito, sir, hindi ko alam, ba't hindi siya nag-run?
Hindi, may object ka na sa baba. Na-download mo na yung dot. Sa object.
Ito.
Yeah. Tingnan mo, i-view mo siya. Ayan, no? Ayan. No?
Okay, okay.
Okay na. Okay na yung ano mo. So,
Okay, sir.
Never mind na muna yung ano yung working directory. Basta importante yung ano natin, yung na-download mo na yung ano.
Okay, sir.
Yung, okay,
Yes, sir.
sige. Alright. Sige. Thanks, Richard. Okay, so sige guys. So let's now, let's take a look at our data first, yung data natin. Okay, ano nangyari sa ano ko? Yan, okay. So simple lang yung ano natin guys, simple lang yung data natin. You have here admit, which is a 0 and 1. 0 and 1 lang yung values niya. And then you have GRE. GRE is, nakalimutan ko meaning na, pero it's parang measure siya. Parang SAT, no? And math, parang ganun siya, no? It's a measure of IQ, something like that. And then GPA is the grade point average ng high school. Tapos here, rank ng ano to ng high school. Okay, and then we have here admit. If that student applicant got admitted in the college. So itong school na to, parang gumagawa sila ng model in order to predict whether based on GRE score and GPA score and the rank of the school, ma-admit ba yung student or hindi siya ma-admit. Okay, so 0 means not admitted. So this student 1, hindi siya na-admit, ang GRE score niya 380 and then GPA niya 3.61. Okay, samantalang si student 2, admitted siya, 660 yung GRE and then GPA 367. And by the way, student number 2 came from a third class high school. So yung rank to 1 means siguro premier na premier na high school. 2 is good, 3 siguro is average and 4 is medyo below average na high school. Okay. So, maraming problem sabi natin guys ang nagre-require ng logistic regression. Anong difference ng logistic regression sa multiple linear regression? Pag multiple linear regression guys, yung dependent variable natin is a continuous variable. Diba last time yung wage, diba? That's a continuous variable. Ito ngayon, ang iprepredict natin si admit. So 0 or 1 lang siya. So a multiple linear regression, although it will work here, it will not be the best way to model. Kasi technically guys, pwede naman natin masabing numeric yung 0 or 1 yun. Although integer siya, tingnan natin guys, let's see here. Tingnan natin yung structure ng dot. Let's see. Bagal talaga mag-run. Ayan. Okay, so ano yung structure niya? Admit is an integer, GRE is integer, GPA is numeric, and then rank is integer. Okay? pwede naman natin i-convert yung admit na yan into numeric eh. Okay, but that not and then use multiple linear regression, but not that will not be the best way to solve this. No? Kasi 0 or 1 lang yan eh. 0 or 1. Okay, so okay. Go here. Okay. Now, si admit at saka si rank, hindi siya pwedeng hindi siya pwedeng i-treat as character, as numeric, no, or integer. Kailangan we should convert them into factors. Kasi admit ginagamit natin to classify accepted or not accepted. Si rank naman, class 1, class 2, class 3, class 4. So we will have to convert them into factors. You know, we have met this, we have encountered this, diba, guys? So yung ano natin, yung call out natin si admit dun sa that object natin, and then we will convert it into a factor. As that factor, that admit, and same pa rin yung pangalan, no? That admit, and then that rank, same. So we're just replacing yung mga variables na to admit and rank and make it as factors. So let's run this too. Okay, and test natin structures ni that. And I expect that admit and rank should now be characters or factors. Okay, so it's now yan. So, nagana ba sa inyo din, guys? Bagal talaga
Factor,
ng
sir.
ha? Okay na?
Factor. Yes.
Okay. Sila Ina, okay na? Ang bagal ng ako, grabe. Nagsa-structure lang ako. Hindi pa kompleto. Yan. Admit, GRE, GPA. GRE is integer. GPA is numeric. Rank is factor already. Okay, and admit is factor. Okay, so we're good. We can now use these variables. Okay. First, let's check. Siyempre, kailangan natin, guys, intindihin yung data natin. We can use the cross tabs function from base R. Okay. And then, ito, ipapaplot natin yung admit nasa y-axis, yung rank nasa x-axis, no? Nasa horizontal, si admit nasa vertical. Usually, pag cross tabs, guys, ang linalagay natin oftentimes yung dependent variable natin sa y-axis at saka yung independent sa x-axis. Data natin is that. Okay, let's run this. Then here you have your cross tabulation. Okay, so sa y-axis natin, 0, which means not admitted. So coming from school number 1, rank 1, 28 yung hindi na-admit, 97 sa rank 2, 93 sa rank 3, number 4, 55, not admitted. Okay, so sa ano naman, sa admitted, no? 1 is 33, admitted, rank 1, 2 is 54, etc. So we can see here that in terms of percentages, no, mas mataas yung percentage ni na-admit, more than 50%. Kasi si school number 1, 33 out of 61. Right? Yung natanggap, no? Si from rank 2, mga ano lang to, mga 54, mga less, of course, and then more than, hindi, out of 100, mga less than 1/3 to, no? Mga 1/3. No? So makikita natin dito, guys, yung proportion ng mga students na receive, na accept, na admit in rank 1, 2, 3, 4 schools. Okay? Of course, you can pwede yung i-modify to X tabs to include percentages. Pero I'll leave that to you guys. That can be done easily. Pwede yung totals dito, pwede yung percentages. Okay. So now, hindi pa natin ginagawa to, no? Yung unang multiple linear regression na ginagawa natin, what we do is we use all the respondents, no? yung lahat ng sample ginagamit natin. Okay? Which is not a good practice. So kunyari may data kayo na 1,000 yung sample size nyo. Ang normal, a person who does not know yung concept ng overfitting will use all the 100 yung size na 100 in 100 observations in modeling the data, whether it's multiple regression, etc. Now, the problem with that is if you use everything, all the samples, then wala kang matitira para i-test yung yung model mo. Okay, so what's being done is actually to partition your data. So ang gagawin natin, yung kasi natin yung data natin, there are 400 observations. We can split the data. So split the data, ibig sabihin, i-partition natin siya, a certain percentage pupunta dun sa what we call the training data. Ibig sabihin, yun ang gagamitin natin para mag-create ng model. Tapos, the next will be yung testing data. Yun ang gagamitin natin para i-test yung data natin. Okay, Chard, yes? May question ka?
Sir, general lang yung question.
Yeah, sure.
Paano meron bang parang cheat sheet nung lahat ng functionalities nung yung ginagamit natin lahat na codes dito sa R?
Cool. Imagine, Chart, there are, let's say, 20,000 packages, di ba? So ang dami nun, di ba? So, may mga cheat sheets, yung mga basics na ggplot2, typr, typeverse, dplyr, yung mga sabihin natin na madalas gamitin at saka yung mga basic na mga na ginagamit. But the others, walang mga walang mga cheat sheet, no? Unfortunately. But it's impossible din kasi to create cheat sheets for all kasi sa dami-dami ng packages. Kunyari sa descriptive statistics, pwede kang gumamit ng site, pwede kang gumamit ng HMIS, di ba? Yung mga ginagamit natin dati, JTools, etc. So sa dami niyan, sana yung sana pwede rin sana yung yung creator ng package niya. Sana gumawa din siya ng cheat sheet. Kaso nasa naman siya, nasa documentation.
Oh, okay, sir.
Di ba may kung nasa CRAN yan, required sila na gumawa ng parang documentation. So what are the functions available there? Ano yung mga parameters na ginagamit sa function na yun? Tapos may example pa. Di ba nakita natin yan?
Yes, sir. Okay, sir. Thank you po.
Okay. So, just to add on to that, kunyari dplyr na package. May cheat sheet yan. Kaso hindi yun yung comprehensive na na laman ng package niyan. There are tons of other functionalities that are present in dplyr, and you can see that dun sa documentation ng dplyr. Okay? All right. So ang gagawin natin dito, guys, split natin yung data natin. Huwag natin gagamitin lahat ng 400 observations. Gawin natin, hatiin natin siya. Okay? And then yung kunyari 70, minsan ang ginagamit 70-30, depende kung malaki yung kung medyo malaki naman yung sample size natin, 60-40, 65-35. It's really up to the one doing the modeling. Yung data set natin, yung observation 400, hindi naman siya gaano malaki, no? So we will just make it 80% natin sa training data. And then 20% ilalagay natin dun sa testing data. Okay. So paano natin i-split yun? Hindi natin gagawin na, so 400 to, no? 400 times 80% is 320. It's not a good idea to just split this into, kunyari, 1 up to 320. So that will be for your training data. And then observation 321 up to 400, that will be for your testing data. Ulitin ko kasi sabi natin, ang gagamitin natin dito na ratio 80-20. So pwede namang 70-30, pwedeng 75-25. Ito kasi maliit lang yung data, yung sample natin 400, So we will just use an 80-20 proportion. So sabi ko nga, 80% ng 400 is 320. So what we're going to do is yung 320 observations, gagamitin natin yun para i-test, i-train yung data natin. Yun ang i-model natin. The others, yung 80, will be used for testing. Ibig sabihin, after we have come up with the model, i-run natin yung testing data natin dun sa model. Tapos tingnan natin kung ano yung predictive power niya. Okay. Are you getting me, guys? Okay, confirm nga guys kung clear, kung naintindihan so far.
Sir, question.
Sige.
Based ba dyan, sir, meaning madaming partitions ng 80-20 yung gagawin natin?
Hindi, isa lang. Dalawa lang. No? Yung 80% ng data natin, yun ang gagamitin natin para i-run yung model. Okay, so di ba magkaka-model tayo? Kunyari, isipin natin muna regression to, multiple regression. So, gagawin natin, split natin yung data natin into two. Okay? Yung isa, gagamitin natin yan para i-run yung LM natin. And then after that, gamitin natin yung the other part, no? Para i-run yung model natin. Tapos para makita natin kung ilan yung percentage na tama yung prediction.
Okay, sir. Thank you po.
Okay? So in this case, 80-20 yung gagamitin natin. Now, as I said guys, hindi mali yung 1 to 320, okay, observation 1 to 320. Isang set, ito yung training data natin. Tapos observation 321. Kunyari, asan si 321? 321, ito. From here down, yun na yung testing data natin. Now that's not a good idea. Bakit? Kasi baka nung nakuha natin yung data na to, naka-sort siya in particular, no? Kunyari, naka-sort siya into admit. So lahat 0 muna, tapos the rest 1 sa baba. So pag ganun ang ginawa natin na 1 up to 320, pwedeng halos lahat ng 1 up to 320 kasi naka-sort nga siya, halos lahat yun 0. Diba? Nakukuha niyo ako, guys?
Yes, sir.
The rest, guys? Sila Ina. Feedback please, guys. I want to know kung nawala si Ina. Ina and Samya, are you getting me?
Yes, sir.
Okay. Sure, sure. Nakukuha ako, Okay, Samya? Okay. All right. Just one last time, no? You're given this data. Hindi natin alam kung paano na-generate yung ordering nito. It's possible na sinort niya, admit lahat 0 muna, tapos saka 1 lahat yung susunod. Let's suppose guys na just for the purpose of discussion. Kunyari, 350 yung 0. Yung admit is equal to 0. Tapos kung ang ginawa nyo guys, hindi nyo rin-randomize yung pag-sort, pag-partition ng data, you will have now yung trained data mo, lahat 0. Lahat 0 yung admit. Okay? So, wala na, hindi ka na makakapag-generate ng model kasi lahat yan 0 na eh. Diba? So, that's a bad way to partition your data. That's why dito gagamit tayo ng sample function. Okay? So first, naalala itong set.seed, no? Set.seed, 1, 2, 3, 4, para yung randomization natin pareho. Okay, here we're creating an object called in. This is an index. And then gagamitin natin yung sample. Yung sample na function. Okay, so sabi ko nga, di ba guys, it's always good to sample. Tingnan natin kung ano ba yung sample na function na yan. Always seek the help of R. Sa inyo ba guys, mabilis mag-generate ng ano? Nag-generate na kayo ng ano ng help function dito.
Last time, sir, yes.
Meron na? Tagal. Okay, but anyway, guys, it's always good practice to bagal ng ano ko. Sa machine siguro medyo full na to, no? Nag-generate na sa inyo guys ng ano ng help function example. Hello.
Running pa din, sir.
Running pa rin. Tagal lang. Yung iba, guys, pa-feedback naman please, yung iba.
Mabagal din sa akin.
Mabagal din. Okay. Sample lang yan, ha? Sample function lang yan.
Yung ni-recommend sa akin, sir, 2 question mark.
Pwedeng usually pag package, mas magandang 2 question mark. Pero pag ano lang, pag function lang, yan, lumabas na, no? Okay, sige, anyway, ano ko yung 2 ano, ha? Ganun din, eh. Nung na-notice ko naman, pag package, minsan hindi niya rin na-run pag isang question mark. Same speed din, ang bagal. No? Okay, anyway, so nakuha ko na yung sample dito, no? I'm using the base, sa base yun, eh. Sa base R. Okay, if I click here, random samples. Yeah, so sample, guys, from base R, it will give us now the syntax, no? Sample X, tapos anong size, saan siya manggagaling, replace is equal to true or false, and then probability is equal to none. Okay, so take a look at this, guys. I'm creating an object called int. Okay, I'm using sample. X is dalawa. So I'm going to split our data, okay, into 2. Okay, n row. Ano yung size? Yung row ng dot natin, ng object dot. Okay, n row is equal to dot. And then replace is equal to true. Kasi 1 or 2 lang naman, eh. So, parang nag-draw out lang siya ng 1 or 2. And then probability is equal to 0.8 at saka 0.2. So, ano mangyayari dito, guys? Magge-generate siya ng ng random numbers, no? 1 and 2. And then 400 lahat, okay, of which 80% yung 1 and then 20% yung 2. Okay, so let's run this. Run natin tong int. Dapat guys, nag-set that seed kayo, para pareho tayo. And then i-view natin si int. View int. Okay. So, kita nyo guys, no? 1, 1, 2, 1, 1, 1, 1, 2. So compare nga please, feedback. If we're getting the same random collection of 1 and 2, 400 siya lahat. No? 400 lahat. Same ba? Okay. Kung hindi, let me see.
Parang iba yung itsura.
Iba? Sige, okay. Sige, kailangan sabay guys, i-set that seed at saka si in. No? Sabay natin i-run. Okay. Set that seed at saka yung int natin and view ulit natin. View si int. Okay. Okay. Kanina nagkamali ako kasi sineparate ko yung set that seed at saka yung yung int. Kailangan sabay. Okay, so highlight mo itong dalawang to guys. I-run nyo. Okay, and then you should be able to generate this. 1, 1, 1, 2, 1, 1, 1, 1, 1, 1, 2, etc. Okay, kindly chat please or
Yung lumabas, sir, from my end, isang row lang siya, tapos values dun yung 1, 1, 1, 2.
Yeah, isang row lang talaga. Sa akin, isang row lang.
Sorry, okay. Horizontal yung lumalabas sa akin, sir.
Horizontal, I-ano mo nga, sige nga, i-share mo.
Same sa akin, sir. Nasa isang row lang lahat
Sige,
ng
tingnan natin.
values.
Okay lang yun, tingnan natin.
Yes, sir.
Okay. Ganun din dun sa ano yung sa ibang students, ganyan din nangyayari. No?
Okay.
Pero wala naman siyang problem kasi dito
Okay,
na
sir.
lang. Dito lang chart i-type mo sa console end. I-print end mo na lang. Sige, print tapos end. Small p
Ay, sorry.
small p. So yan. No?
Okay, sir.
So 1 2 3 4 5 yung pang 5 2, no?
Opo. So,
Tapos ito etc. So we have the same random numbers.
thank you, sir.
All right. So saan natin gagamitin yan? Well, ang ibig sabihin nito guys, lahat ng mga 1 that will now go to your training data kasi 80% yun eh. Tapos yung ano natin, yung lahat ng 2 that will now go to your testing data. So random to, no? Randomly generated tong index na to. So 1, all the number 1s will go to your training data and then all your number 2 will go to your testing. Kaya nga tingnan nyo to guys. Okay, so we're now creating this object called train, and then it's from the dot object, and then lahat ng index that will row, no? Yung row guys, yung row natin will be yung galing sa index is equal to 1. So what's that? Row 1, row 2, row 3, row 4, row 6, row 7, etc. Yun sila papasok sa training data. And then lahat ng columns kasama. Si test naman guys, lahat na may index na 2. Okay? So run natin to. Okay? So we now have 2 objects guys. Training and testing. Si training, 325 observations. Hindi siya eksaktong no? Hindi ineksakto ni R na 80% ng 400. May konting deviation. So si test 75. So all in all to 400. So tingnan natin guys yung train data set. Okay. Notice guys, ano tong mga observations na to? 1, 2, 3, 4. Wala si 5, di ba? Wala si 5. Tama?
Salad.
Tama, guys?
Yes, sir.
And then, ano napunta kay testing data set? Ayan, no? 5, 14, 16. Lahat ng number 2 dun sa index. Dito siya linagay sa sa testing data set. Okay?
Okay, sir.
Alright. In fact, guys, yung yung regression natin, we could have done this, no? Kasi hindi ko na muna kasi ang focus natin nun mga concepts ng multiple linear regression. So since medyo na tayo at isa tayo sa mga natin dito, functions, I'm now introducing this, which is actually an machine learning tool. Yung pagpa-partition machine learning concept. Okay. So ang gagawin natin guys ito, ang i-run lang natin yung train. Tapos magkaka-model tayo, i-check natin yung model natin if it will run well also sa testing data. Okay. Now, mag-ano na tayo guys, mag-regress na tayo. No? So you know this, we're creating an object called my model and then we're using LM. LM, ang response variable is admit or dependent variable, and then we're regressing it on GRE, GPA plus rank. Data is equal to train, summary is equal to my model. Sige nga, pakiran nga yan guys. And then tell me what happened.
May error, sir. Nakalagay yan. Oops, that factor R2, not meaningful for factors.
Okay, about the rest.
Same sa akin, sir.
Same, no? Sorry guys, medyo nag-munch na ako. Okay, same. Now, bakit guys? All right, why? Why? Bakit guys? Kasi si LM, linear model, dapat yung ano niya, response variable dapat continuous variable. But here we have a factor, si admit. So hindi magra-run yan. Hindi pa pwede kasi ang condition ng LM dapat si dependent variable should be continuous. Okay, so ang gagamitin natin guys, not the LM but rather the generalized linear model. Ito, yung GLM na to. Ito yung ginagamit pag binomial, pag Poisson, pag iba-iba pa. Tingnan natin na GLM. Ano yung mga family yan? Maraming family yan guys. Here. So GLM is from stats. Alright, used to fit generalized linear model specified by giving a symbolic description of the linear predictor and a description of the error term. No? So ito, ganito kahaba yung ano niya, yung if you really want to be very specific. Tapos dito, meron ditong family, as in family. And family, no? Here. So yung family guys, iba-iba yan. So tingnan natin dito, family, description of the error distribution. For GLM, this can be a character string. Okay, let's see family here. Yan. And ang mga family guys, binomial, Gaussian, gamma, inverse Gaussian, etc. Okay, for this subject, we're just going to look at yung binomial natin. So you can see here guys, we're using GLM. We're creating an object called mod. Admit, regression, GRE, GPA rank, data is equal to trained data. No? And then we have to specify yung family niya. Family is equal to binomial. So let's run this. Run natin, run. Okay. So here is our model guys. So we have the intercept. Okay, so y admit is equal to this one, -5. And then si GRE is not significant. No? GRE is not significant. GPA is significant. Rank 2, hindi siya lumalabas na significant. Rank 3 and rank 4, significant. So kahit na hindi significant si rank 2, of course, isasama pa rin natin yung variable na rank. No? Okay. So clear so far, guys? Clear so far? All right. Now, ang pag-interpret nito, hindi siya pareho ng ano, guys. Hindi siya pareho ng multiple linear regression. Okay? So I'm going to explain that now. Kasi yung y natin dito, yung admit, and itong function na to, yung binomial, ang ginagamit niya for your response variable is what we call the log odds ratio. Okay, so let me explain that in a while. Now, pwede rin guys na, kasi anong nangyari dito, bakit nga pala wala si rank 1? Bakit wala si rank 1? Bakit rank 2 lang?
Siya yung source, kalimutan ko yung tawag sir, sorry.
Okay, ginawa siya benchmark, di ba?
Yes, sir.
Factor kasi si rank di ba? Rank 1, 2, 3, 4. So, yung rank 1, siya yung alphabetically unang makikita. No? So, siya yung ginawang benchmark. So, the rest here are interpreted in relation to rank 1. So, ano ibig sabihin itong, kunyari itong negative 0.57. So, on the average, okay, rank 2, a rank 2 student has 0.57 log odds ratio less than rank 1. Okay. take note, in-interpret ko to as log. Ito dito, log odds. Okay? Log odds, no? So, 0.57 less log odds ratio compared to rank 1. Okay? Which, practically guys, ibig sabihin ng mas lesser yung chance ni rank 2 na ma-admit compared to rank 1. Kasi we know rank 1 is, these are premier schools, no? Premium schools. Okay, so, now pwede guys, pwede natin gawing si rank 1 kasama, pero tatanggalin natin yung intercept. Okay, remember guys, ano ibig sabihin ng intercept dito? The intercept here means this is the log odds ratio of a person, of a rank 1 person who does not have GRE, 0 GPA. Diba? Kasi intercept, that's the value of your predicted value of your Y when all your independent variables are 0. So 0 GRE, 0 GPA, 0 rank 2, 0 rank 3, 0 rank 4. Sino yun? Kung hindi siya rank 2, hindi siya rank 3, hindi siya rank 4, hindi siya rank 1, di ba? Yun ang ibig sabihin nun, di ba? So zero out lahat ng mga to, matitira negative 5. Okay, so how do you interpret this? On the average, a rank 1 student has negative 5 log odds ratio of being admitted to that university. Pero kailangan i-explain natin kung ano yung log odds na yun. Okay. So, ano naman kung si rank 2 guys? Si rank 2 na walang GRE, GPA. So ano yung intercept ni rank 2? So nangyari yan, kasama si negative 5 and then 0 GRE, 0 GPA, rank 2 kasama negative 0.57 and then 0 yung rank 3, 0 yung rank 4. So what will happen is that you're going to add negative 5 at saka negative 0.57. Okay? So ang intercept ni rank 2 is negative 5.57. Diba? So it's lower than the intercept of rank 1 which is negative 5. And of course, si rank 3 naman, negative 5 at saka negative 1.12. So that's negative 6.12. Okay, so mas mababa yung mga log odds ratio ni rank 2, rank 3, rank 4 compared to rank 1. Okay, kindly confirm please kung naintindihan yung at least yung ibig sabihin ng mga intercepts na yan. Clear ba, ladies and gentlemen?
Yes, sir.
Okay. All right. Okay, so let's go here, guys. If we want, guys, yung rank 1 to appear as part of the intercept, kailangan tanggalin natin tong intercept na to. And how do you do that? Ima-minus 1 yung dito. Take a look at this model. So GLM pa rin, admit regress on everything, di ba? Ibig sabihin everything. Minus 1. Ibig sabihin ng minus 1, huwag isasama si intercept. Pareho din data is equal to train, family is equal to binomial, and then summarize natin. Okay. Look, guys. Okay? So ito yung intercept ni rank 1, di ba? Tapos ito si rank 2, di ba? Inad natin yung 0.57 something kanina, di ba? Tapos si rank 3, rank 4. So nag-appear lahat ng rank 1, rank 2, rank 3. Wala na yung intercept. So this is another way to model it. Pareho lang naman yan eh. No? Pareho lang naman yan. And the interpretation will also be the same. If you use GPA 1.166, pareho lang ba dito? 1.166. So practically the same. Okay? Clear guys? Clear to yung kasama si rank 1 dun sa sa factor.
Ano yung mas preferred dun, sir?
Pareho lang eh. Same lang siya kasi pag importante naman dito, 'di ba, i-interpret mo siya. So ano ibig sabihin ng negative 5? Ano ibig sabihin ng negative 5.58? They're the same. They're equivalent models, no?
Okay, sir. Thank you.
Kasi ito, tinan mo sorry Richard, hindi ko lang to yung sa question mo. Ano ibig sabihin ng negative 5.009 dito? Ibig sabihin niyan, this is the value log odds, no? Log odds value ni rank 1, no? Na walang GRE, walang GPA. Okay, ito wala kasi rank 2, rank 3, rank 4 yan. Diba? Okay, how do you interpret this now? What's now negative 5.009? That's also the log odds ratio of rank 1 na walang GRE, walang GPA. Kasi hindi kasi sasama tong rank 2, rank 3, rank 4. Diba? Right? So it's the same. They're equivalent. They're equivalent models.
Question, sir.
Yes.
Paano kung madaming non-numerical na factors na kailangan maging benchmark? Kunwari, iba-iba. Tapos, based dun sa sample niyo, sir, yung pagtanggal yung rank 1, siya yung nagiging most likely yung intercept. Paano pipili yung model kung madaming factors na similar dito na may benchmark ka for each variable?
May benchmark ka for each variable. Ano yung question mo ngayon?
Kunwari, sir, itong rank 1 and 4, itong variable na to, meron ding similar na variable na parang dalawa yung may benchmark.
So you have another factor.
Apo, another factor.
May isa pang variable na
Apo. Paano kunwari, sir, ibig sabihin yung intercept ko doon would be yung parang average lang ng dalawang benchmark?
Yung intercept mo doon is the average of...
Kunwari, sir, ngayon, di ba, isa yung benchmark natin, yung rank 1. Kunwari, sir, may variable din na parang may benchmark din ako. Kunwari, similar lang din siya dun sa model. Ibig sabihin, sir, yung intercept is yung average ng dalawang benchmark na yung kunwari.
Okay. That's a good question. Ang mangyayari niyan, maglagay tayo kunyari ng maglagay tayo ng example, no? Kunyari may variable tayo na na year level. Example lang year level. So meron tayong, let's say, 4 na na year levels. Frosh, sophomore, junior, and senior. So pag may ganung variable, papasok yan sa coefficient. Magkakaroon ka ng sophomore, assuming na si Frosh yung naging benchmark. So magkakaroon ka ng sophomore, junior, at saka senior. Okay. Paano mo i-interpret yan? So magiging ang question mo ngayon dyan, ano yung average ng isang rank 1 na sophomore? Kuha. So papasok si rank 1, papasok din yung sophomore na yun.
Okay, sir.
So para magkakaroon ka ng permutations, ng mga combinations, paano si rank 2 na junior? So si rank 2 na junior, ang ipapasok mo sa pag-compute ng slope niya, ng intercept niya, is rank 2, tapos idadagdag mo si junior. Kasi the rest will become 0, di ba? Actually, natin yan. Dapat lesson nga natin ngayon kasi na-corrupt nga yung file. Kasi may mga ganung questions. Ano ngayon yung intercept for yung katulad ng tinanong ni Richard. Di ba? So
okay,
pero hindi pa pwedeng rank 3 na junior at saka sophomore. Kasi mutually exclusive yun eh. Hindi ka pa pwedeng maging junior at saka sophomore at the same time. Diba?
Yes, sir.
So you can only choose one of them. So ano yung intercept for isang rank 4 na Frosh. So pag gano'n, isang rank 4 na Frosh, tatanggalin mo lahat ng sophomore, junior, at saka yung mga coefficient sila. Kasi lalabas dito yon sa model natin. Kunyari dito magkakaroon ng sophomore, magkakaroon ng junior, at saka magkakaroon ng senior. Okay?
Okay, sir.
Alright. Sige. We'll have an example of that pag balikan natin yung multiple linear regression natin. Okay. Alright. So, since GRE is not significant, tatanggalin natin yan. So we're going to create now our model, which is mod. Okay, I'm going to call it mod, and then GLM admit GPA plus rank. Same din guys, same. Dito yung anong pangalan ba natin dito? M1 dito. No? So I gave it a different name. Dito mod kasama yung rank. And then my question yata. Okay. So here i-override ko lang yung pangalan ng model para isa lang siya. And then here, si mod natin will now be our model where we're using GPA at rank. So no more GRE. Tatanggalin natin siya. No? Okay, so run natin to. Okay. So ito na guys. No? Ito na. Take note guys, si rank 2 dito, not significant. Pero hindi natin siya pwedeng tanggalin kasi intercept yan. Remember guys, yung intercept, kahit na hindi siya, kahit hindi siya significant, sinasama pa rin natin siya. Okay, clear so far guys? So we're going now to interpret itong itong model natin. So this is now our model. No? So our model is negative y admit is equal to negative 4.72 plus 1.3735 and then minus 0.5712 times rank 2 minus 1.1645 times rank 3 and then negative 1.5642 times rank 4. So that's now our model. Okay. All right. So mali yung pag-placement ko dito. Okay. Dapat inuna ko to. Okay. So let me go here first. And then babalikan ko yung prediction. Okay. Bago natin i-predict guys, tignan muna natin yung equation natin. Okay. Kanina sabi ko guys, yung equation na to, yung admit function, y and then admit is equal to, di ba, ang alam natin sa multiple linear regression, beta null plus beta 1 times x1 plus beta 2 times x2 plus etc. So here in our model, beta null plus beta 1 times GPA plus beta 2 times rank 2 plus beta 3 times rank 3 plus beta 4 times rank 4. Diba? Kasi tatlong rank na pumapasok sa atin. And then it's equal to ito, log odds ratio. Okay. So itong P, itong quantity na to, P divided by 1 minus P. This quantity, guys, is called your odds ratio. Odds ratio. It's the probability of being admitted minus the failure not being admitted. Kasi P is the probability na ma-admit yung student, 1 minus P is the failure rate. So it's the success over the failure. Ang tawag doon, log odds. When we do logistic regression, guys, ang ginagamit is the logit. Ano yung logit? Si logit ito, yung log nitong odds ratio. Okay, so logit is equal to log ng odds ratio. Okay, so ang tawag din dito odds ratio. No? So what's the meaning of logit? It's equal to the log of the odds ratio. Ito yun, guys. Log or ln ng P over 1 minus P. Okay, clear so far, guys?
Yes, sir.
Okay, so kanina sabi natin, di ba, yung GPA, ang coefficient niya is 1.3735, di ba? So ano ibig sabihin ng 1.3735 na yan? So GPA, okay, which means that for every 1 unit increase in GPA, okay, the log odds of being admitted increases by 1.375. 1.375. Okay, so nanggaling 1.375 dito sa coefficient mo. 1.373 pala. Control C. Okay, so medyo ibang klase yung logistic regression. Ganoon din sa multinomial, guys. Ang difference ng ng logistic at saka multinomial, si multinomial more than 2 yung factors natin. Okay, so mas complicated siya ng konti. Pero once you know logistic, guys, once you know logic, alam mo na rin guys yung probit. Alam na rin natin yung sa multinomial. Okay, so again, how do you interpret this? Okay, for every 1 unit increase in GPA, okay, the log odds of being admitted increases by 1.3735. Okay, so may nakasamang log odds, you know. Hindi yung katulad ng multiple regression, depende dun sa dimension ng independent variable natin. Ito, guys, laging log odds yung yung now, mahirap interpret yung log odds, no? It's really quite difficult to interpret it. Okay, but we can actually determine, guys, we can compute for your probabilities. Kasi yung probability madaling ma-interpret kaysa yung log odds. Dahil gagamitin ko lang itong ko. Okay. Let me explain, guys. No? Let me open my digital pen. Then let me explain mathematically ano nangyayari dito. Yung log odds natin. Okay, so let me open my digital pen. Excel na lang. Excel na lang. Okay. Ito, DA, Data Development Analysis. Isang ina-advise ko sa undergrad. Familiar ba kayo, guys, sa DA? Na-meet nyo na ba siya? So, okay. Okay, so wala. Wala na ba ito naman? So, view. And start thinking. Okay. So let me just explain, guys, kung ano yung para hindi tayo nagugulat kung ano yung ibig sabihin ng log odds. Okay, so let's start with the concept. Di ba yung regression equation natin, y is equal to yung value ng natin, y sa logistic regression is the log of p over 1 minus p. So I said this quantity here is your odds ratio. Odds ratio. So that's the ratio of the probability of being accepted divided by the probability of not being accepted. Okay, so pass or fail, no? So pag in-interpret natin, guys, yung B0 plus B1 times GPA, di ba? Plus B2 times your rank 2 plus B3 times rank 3 plus B4 times rank 4. So when you interpret this, it's always in terms of log odds ratio. Okay? And as I said, it's difficult to interpret log odds. Kaya gawin natin, guys, anuhin natin? Baguhin natin. So let's now convert yung value na to into something. So equal naman tong y at saka ito eh. So let's remove yung log para mawala yung log na pag-interpret natin. So how do we remove the log there? We will just exponentiate. No? So raise it, e to the y is equal to p over 1 minus p. Diba? Kasi ang exponential ng log will just cancel out. There are inverse functions yan. Okay, so ano nga guys? Paki-reply kung clear so far.
Question, sir.
Yes.
Applicable lang yan sa two contrasting independent variable?
Two contrasting independent variables. Hindi. Kahit ilan yung independent, kahit ilan yung ano niyan. Kahit kunyari may B5 ka pa dyan. Kunyari times, let's say, region kung saan nanggaling yung estudyante. Tapos, this is what you're referring to, times B6 times whatever. So kahit ilan yung regressors yan, it will always be equal to y. It will always be equal to log of the log odds ratio. It's the same as multiple linear regression, only that yung y natin hindi yung units ng dependent variable. It's the log odds ratio.
Okay, sir.
Was that your question, Richard?
Yes, sir. Additional clarification, sir.
Sige.
Yung understanding ko dun sa log odds, baka mali din.
Oo.
Ano, sir, kunwari yung dependent ko is default rate, yung independent ko, let's say, yung variable is yung isa low income individual tapos high income individual. Tama pa yung interpretation ko, sir, na
Wait mo nga. Written mo, ano yung ano?
yung
Ano yung-
variable ko, sir, is
Oo.
if an individual is high income or low income.
High
Tapos,
income.
Oo.
Tapos low income.
Opo.
Okay?
Tapos yung log odds is yung probability na magde-default yung low versus sa high. Yun ba yung application nun, sir? Or it's a different ano?
Hindi iba yun. Kasi ang variable mo, ang dependent variable mo is whether magdi-default o hindi.
Yes, sir.
So ito, independent variable to. No?
Yes po.
You will use this to predict whether magdi-default o hindi. Diba? Ang dependent variable mo is
Default.
is pay, be able to pay or not pay.
Yes, sir.
Oo. So, yung high or low, kung high or low income siya, that would be one of your variables to predict kung magdi-default siya or hindi siya magdi-default.
Opo.
So, what you can, so magiging ano mo niyan, not default, pwedeng 1 yun. No? And default, 0.
Okay, sir.
So, ang log odds ratio mo is the probability na magbabayad siya, diba? Yung hindi siya magdi-default over the probability na magdi-default siya, not pay.
Okay, sir.
Bali, may log yan, no? Log ng magbabayad versus hindi magbabayad. Ito, log ng ma-admit versus hindi ma-admit.
Okay, sir. Thank you, sir.
Alright. So, since the value that we're getting dun sa logistic regression natin is the log odds ratio. No? And sabi natin, ang hirap i-interpret ng log odds. So, i-convert natin yung log odds into probabilities. Kasi yung probabilities mas madaling maintindihan. Kunyari, log odds, kunyari, negative 0.93. So, paano ano yun? For every 1 unit increase in whatever that variable is, there's a negative 0.93 decrease in the log odds of paying. Diba? Parang gano'n yung log odds ng paying. No? So medyo mahirap siyang i-interpret. Okay, so it's better to convert yung log odds ratio natin into a log odds log odd natin which is equal to yung log ng P over 1 minus P, diba? Okay? So what do we do, guys? Para matanggal tong log na to, we will exponentiate it. E to the log, matatanggal siya. So this is why, diba? Y is equal to this. So if we exponentiate both sides, magiging e to the y to is equal to, maka-cancel na to. So this is p over 1 minus p, which is equal to, di ba, this is your odds ratio. Diba? So this is your log odds ratio. This is your odds ratio. Nawala na yung ano, nawala na yung log, no? Okay, and then so kailangan na lang natin guys, kailangan natin ma-solve yung p. We need to solve the p, no? Kasi y is your admit eh. Ito yung admit natin, no? Okay? So how do we solve for the p? Okay, so i-ano natin, well, basic math na lang, ano? Transpose natin tong 1 over p sa kabila, tapos si p sa kabila din, tapos si e over y sa kabila. So magiging 1 minus p over p is equal to 1 over e to the y. Okay, ano nga guys, kung clear yan? Basic ano lang yan ha, basic arithmetic. Nag-transpose lang tayo. Clear ba?
Yes, sir.
Okay. The rest, asa na yung si Ina, Samya, clear ba?
Clear, sir.
Okay, thank you. Okay. Okay, so finally guys, ang gusto natin ma-compute kasi yung ano, we want to compute for your P, yung probability. No? So what do we do with this? Well, ano lang natin, i-distribute natin yung P dun sa numerator. This would be 1 over P minus 1 is equal to 1 over e to the y. Yan. Okay? Therefore, 1 over P is equal to 1 over e to the y, then plus 1. Yan. Okay? And then finally, okay, tapos ito, finally, which is equal to a common denominator, e to the y, no? And then 1 plus e to the y. Okay, therefore, our p is simply the reciprocal. P is equal to e to the y over 1 plus e to the y. Good. Okay, so that's how you convert your your probability, no? Diba? Which is what? Which is lastly guys, this is actually equal to, so kung gagawin natin kunyari sa ano to, sa R, sa Excel, this is equal to, the probability is equal to E, exponential ng ano, exponential nino guys. Ano tong Y? What's Y? Y is your, di ba ito? Log odds ratio. So that's exponential ng log odds ratio natin divided by 1 plus exponential ng log odds. Okay. Yan ang equation guys. Ha? So, three things ang tinitingnan natin dito. No? Si log odds, pag tinanggal mo yung log niya, magiging odds siya. Okay? Tapos si log odds, pwede natin ma-compute into probabilities. Mamaya kasi ipa-plot natin tatlong to. Tingnan natin kung ano yung relationship nila. Okay? So log odds guys, yung 1, ito P over 1 minus P. And then, log odds is the log of P over 1 minus P. Si odds is P over 1 minus P. And then si probability is exponential of log odds over 1 plus exponential of log odds. Okay. Hindi nyo ba diniscuss to guys sa ano? Sa regression? Hindi kayo na ganito, no? Tama ba? Hello?
Hindi ko din maalala, sir.
Okay. Diba? Okay. Yes, sir. No, sir. Ano yung sabi? Ano yung yes, sir? No, sir? Okay. So, just take note of that. No? So, balik tayo dito sa ano natin, sa R. Okay. So, kunin natin guys yung mod. Ito yung object natin, di ba? Mod dollar. Tingnan mo natin guys, ano ba yung mga ano yung laman ng ano ng mod ano natin, ng mod natin. If you take a look at our objects here, mod is a list, no? I-click mo yan guys. It's a list of 30 objects. No? Yan, coefficients, residuals, fitted values, marami siyang laman. Okay, so ito yung names ng mod. Yan. Right? Names of mod na object, yan siya, marami siyang laman. So, let me just look for the coefficients. Okay. Diba ito yung coefficients niya? Intercept, GPA, rank 2, rank 3, rank 4. Okay, so if you're going to write this equation, di ba sabi natin y is equal to negative 4.72 negative 4.72, 73 plus 1.37 times GPA minus 0.57 times rank 2 minus 1.16 times rank 3 minus 1.56 times rank 4. Yun ang model natin. Okay, that will be our model. Okay, so let's take a look at others. No? Ano pa ba yung makikita natin dito? And then yung residuals. That's the difference between the actual value and the predicted value. And then si fitted value. Okay, tingnan nga natin guys. Tingnan natin yung first three. Head, mod, and then fitted values. And then just the first four. Okay. So ito guys yung ano, ito yung fitted values 0.28, 0.29 o 0.3 at saka 0.68 at saka 0.12. Okay? Let's check guys kung ito nga yung mga fitted values natin. Tignan natin So for sample 1, for observation 1, it's 0.28. So tingnan natin kung 0.28 nga ba yung lalabas. So mod coefficients. Okay. Copy natin guys. Control C, Control V, and then plus. Plus natin to. Okay. So ito yung intercept, di ba? Negative 4.27 plus 1.37 na okay. Tingnan natin guys si training data set natin. Okay. This is observation 1. Di ba? So how do we compute for the predicted value? How do we compute for the predicted value? So see observation 1, so this is the intercept plus 1.373 times GPA. Ano yung GPA niya? Ano yung GPA niya, guys?
3.61, sir.
3.61. So i-replace natin to, no? Control C, Control V. And then ito, ano mangyayari dito, guys? Rank 2 to. So,
0.
0 siya. So, times 0 to. No? Times 0. Hindi siya papasok. Tapos ito,
Times 3.
times what?
3, sir.
Times what? Times 3. Times 1. Diba?
Okay.
Kasi rank 3 siya, so papasok kung saan yung 1.16 to. 1.16. So, itong coefficient na to papasok kasi rank 3 siya. So, hindi times 3 times 1 lang kasi ibig sabihin nun, this intercept will enter the model, diba? And then plus ano to? Negative 1.56 times ano to?
0, sir.
0. Alright? So, ayun, no, di ba? Ito pang rank 4 so hindi siya papasok. Ito pang rank 3, so times 1 siya. Ito pang rank 2, so hindi siya papasok. This is your GPA, 1.37 times 3.61, and then this is your intercept. Okay? So let's run this. Ano yung predicted value nyo guys for sample 1?
Yung actual, sir, 0, admit.
Ito, di ba? Hindi actual. Yung predicted value. Ito, di ba? 0.28. Okay. Guys, yun na to. Head, yung ano natin, model, and then pinaano ko yung fitted values, and then yung first 4. Okay, 0.28 yung predicted value niya. Pero when we computed, guys, it's 0.93, negative 0.93. Bakit magkaiba? Hindi siya pareho.
Siguro, sir, yun yung may portion ng unexplained ng model.
Kasi ano to di ba? Ito yung predicted value natin using the model, di ba? We use the model. Ito yung mga coefficients natin. Negative 4.73, etc. So whatever we get here should be the predicted value. Pero nung kinuha natin yung predicted value ng model natin, yung first observation is 0.28.
Hindi ba sir yung log odd?
Okay, that's the answer, no? Ang binibigay sa atin dito is the probabilities. Ito, log odds to. Log odd ratio to. Okay, but if we convert that, paano natin ko-convert yung log odds sa sa probability, di ba ito? Di ba? To convert your log odds, your y, into probabilities, ito yon. E to the y over 1 plus e to the y. So if we follow that, guys, this will be equal to exponential e to the y. Ito yung y natin. Control C, Control V. Okay. Divided by, parenthesis, divided by 1 plus e to the y. There. Sige nga guys, pakirun. What are you getting?
Wait, sir.
Sorry.
Same, sir, sa dun sa predicted value. 0.28 to 295.
Same sa probability. Siguro may konting lang yan. Kasi may mga rounding off tayo. Okay, did you get the same answer, guys?
Yes sir.
Okay, good. So, yung fitted values dito, guys, ang binibigay sa atin ni R, hindi yung log odds, it's already the probabilities. Kasi nga, mas kailangan natin na yung probability. In fact, sige, ano natin ha? Kunin ulit natin yung ano. Let's copy this. Control C. I-copy natin siya. Tapos, pinag-run. Tapos, i-ano natin yung train dataset natin. Head. Train. Train yung ano, yung admit. Yung admit natin and then first four. Let's take a look at this, guys. So dito, ang ginawa niya, okay, alam mo siya ng konti. Dagdagan natin. Control C, Control V. Let's make it 10. Tapos ito, round na lang natin. Apa ng decimal, round lang to 3 decimal places. Ito na lang. Ito is 3. And then, so yan ano. Tapos, i-ano natin head ni train data set. Alright. Ay. Head. So, admit variable. And then 10. Okay. Let's compare, guys, yung ano. This is the predicted value. Diba? 0.282. And then, yung actual is, na-admit ba siya o hindi? Guys, ito yung actual value. Ito. Ito ba yung train yan? Yung train. 0, di ba? 0. Hindi na-admit. So, what was the probability of being admitted, guys? Hello?
28%, sir.
28%. Ito, di ba? Ito yung mga probabilities na ma-admit siya. 0.28. Tapos, ang actual, hindi nga siya na-admit. How about observation number 2? Probability na ma-admit siya, 0.29 or 0.3. Na-admit ba siya?
Yes, sir.
Yes. So if we're going to use 0.5, so mali ito, di ba? 0.29. No? Okay, sige, magtatawag na lang ako. Samya, how about number 3? Comment nga sa number 3 observation.
Yung
Samya?
68%. Hello?
Yeah.
Yan, sir.
Sorry.
For number 3, sir, yung
Yes.
probability is
Yes.
68%.
68%. And then, ano yung
Yes.
actual? Na-admit ba siya?
Yes, sir. Ako.
Ano, si number 3 ito. This is the train data, guys. Na-admit siya. Probability, 0.68. So if you're going to use 0.5 as a cutoff, okay siya. Tama itong prediction natin. And then this one, 0.129 sa fourth. 0.129 yung probability na ma-admit siya. And yet, na-admit
Na-admit
siya.
pa rin.
Oo, na-admit. So mali ito, no? Again, assuming na ang cutoff natin, 0.5. Okay, so here, in the first observations pala, makikita natin na may mga misclassifications, no? And that really happens kasi di ba? Kasi modeling to, and we expect to have some error terms, no? Okay, so let's go back here. All right. So ito, guys, diniscuss ko na. Okay, I already discussed this, so we will not yung pag-convert, no, into a probability. Okay. So and this one, the validate. Validate natin si individual tree, ganun din. Kinompute muna natin yung odds ratio. And then convert natin si odds ratio into probabilities. Ito yung number 3 kanina, from 6 to 8. Okay? So, alright. Now, balikan natin dito. No? Okay, here. Okay, let's now predict, guys. Let's now predict based on log odds and probability values. Kasi sabi natin, di ba, when we compute for the value of y, yung predicted value ng y natin, pwedeng express yan as log odds, pwedeng expressed as probabilities. So we can generate both. No? Here I'm creating an object called P1, okay, and then we're using the function predict. Okay. So predict using the model, okay, and the data is the trained data. So let's have the first 6 observations of the prediction printed. No? I-run natin to. Let's run this. Okay, so what do you see, guys? Negative 0.93, negative 0.85. Ano to? What's that? What does this generate? Ano generate ito, guys? Generates what? Naalala itong 0.93 na to, negative 0.93. Ano siya? Those are the
Log.
yes, correct. Those are the log odds values, no? Log odds values. Okay. However, we can also napakita natin kanina, di ba, yung fitted values, no, dun sa mod. Yun na yun, or ito, pwede nating ano din dito, no, i-generate, predict din, mod train, kaso ilalagay natin type is equal to response. So if we use this type is equal to response, ang i-generate naman niya is, what did it generate, guys? The probabilities. Diba? Probabilities. Generates the probabilities. So these are equivalent values, guys. No? Only that, sabi natin, mas madaling interpret si probability. Kasi ito, the probability of being admitted is 28%. Okay, and if we're going to use 50% as a cutoff, so dapat hindi ma-admit to, no, based on this model. Okay, so pause muna ako, guys. Clear yung guys. Nakita natin na we can generate both the log odds values and the probabilities using the predict function. Okay, paki-chat or paki-unmute kung clear so far, guys.
Here, sir.
Clear, sir.
Okay, thank you. All right.
Clear, sir po.
Thank you. So, now, ang gagamitin natin, just like a while ago, ito nagawa na natin, no? So, P1A is actually your probabilities. Ito yun. Tapos si head train, i-ano lang natin pasok lang natin si admit, no? Okay? Admit. This will give us the first 6 values and first 6 values nito. Okay. Ginawa na natin ito kanina, no? So ito, 0.28, not admitted, okay yung probability natin. 0.29 o 0.3, admitted. So again, ang assumption natin, 0.5 yung cutoff natin. No? If it's greater than 0.5, admitted, less than 0.5, not admitted. So 1, 2, 3, 4, walang number 5. Bakit walang number 5, guys?
Nasa
Testing
yung
data.
20%, sir.
Oo, tama. Nasa test data. Okay? Alright, very good. Alright, so, okay. Dapat mag-run to pag minute na lang. Okay, so dito, guys, how do we interpret the results? I think we already, we already discussed this, ano? Parang ulit siya. And then, okay, na-discussan natin to yung difficulty ng pag-interpret ng log odds. That's why it's better to convert it into probabilities. Okay, so validation yan. Okay, now we go here, guys. Okay, isa-set natin na ang ano natin, ang cutoff is 0.5. Actually, guys, sa machine learning, hindi basta-basta ipo 0.5 mo yan. Okay, what is done is we compute for what we call the receiver operating characteristics. I don't know kung na-meet nyo na yung ROC. Na-meet nyo na ba yung term na AUC, ROC? Na-meet nyo na ba ito? Under the curve, receiver operating characteristics. Okay. If not, guys, okay lang. So siguro bibigyan ko lang kayo ng konting brief introduction niya. No? Ito kasi, bakit 0.5 ang gagamitin? Bakit 0.5? So, ano lang yun, parang arbitrary, no? Which is logical naman, no? Kasi kung sinasabi natin na 50-50 yung chance, okay, 50-50 yung chance. So kapag less than 0.5, edi not admit. Pag greater than 0.5, i-admit natin. Okay, so here we're going to create a vector. We call it pred1. Okay, and then gagamitin natin si if-else. I-convert natin yung mga probabilities into 1 or 0. Okay, so related to kay P1 kasi, di ba P1A pa lang? Sorry, P1A, no? Sorry guys, this should be P1A. Oops. Okay. P1A. Ano si P1A probabilities, di ba? Kasi si P1, ano yun eh, mga log odds yun, di ba? Log odds ratio. Okay, so pag greater than 0.5, we'll convert it into 1, otherwise 0. And then, titingnan natin guys yung ano yung head, yung first 10 ng pred1 natin, which is just a conversion of convert probabilities to binary 0 or 1. Okay? Convert natin, i-run natin to. Yeah, okay? So ito guys yung mga yung mga conversion. 001, 00010. Okay, and then i-ano natin yan guys, i-compare natin with yung actual value. Okay, so iwanan muna natin to guys, ito sa nakon. Okay. So we'll go back to that form. May explain ako dyan, ano? Pati ito. So jump muna tayo guys dito. Sorry, may linakawan lang ako, ha? Okay. Ito. Let's go here first to computing for the misclassifications. Yung mga linakawan natin guys, it's just ina-explain ko lang dyan kung yung log odds, at saka yung probabilities. Pero solving muna natin to kasi gusto ko makita kung how powerful our model was. No? Okay, here we're going to create our confusion matrix. So ang function natin, we're creating out an object called tab1. Okay, and then we're going to create a table. Ang nasa y-axis natin, yung predicted values, and it's coming from pred1. Ano yung pred1 natin? Ano guys yung pred1 natin? Ito na yung 0 or 1, di ba? Ito. Di ba guys? Kinonvert na natin yung probabilities into 0 or 1. Right?
Yes, sir.
Tama? Okay. And then, i-compare natin siya with the actual, yung galing yan sa trained data set natin, and then the variable admit. Okay. And then, i-print natin. So, let's run this. Ito na ngayon, guys, yung confusion matrix natin. So, what does this mean? Predict natin na 0 when in fact, 0 siya, 208. Predict na 0 when in fact na-admit siya 73. So mali ito, no? Predict na ma-admit pero hindi siya na-admit. Ang actual yung 0, 15. So yung diagonal dito guys, these are the correct predictions. Okay? And this one are the wrong predictions. So tingnan natin guys yung percentage na tama sa prediction natin. Let's go here. Okay. So dito guys, yung function natin, we'll just sum up the diagonal 208 plus 229 divided by the total of your object tab 1. Okay, so ito na yan. So what was our batting average? 73% yung tamang na-predict. And then, yung, of course, yung na-fail natin, 1 minus, no? 27%. Okay, pause muna ako. Any questions about that, guys?
Question, sir.
Yes.
Yung dun sa matrix na
Hmm.
correct percentage versus
Yeah.
yung incorrect percentage. Meaning sir dito, pipili, to confirm sir, pipili parang yung assessment if the model is good or sorry, if satisfactory or not is magde-decide if yung model is to predict na ma-admit or to predict na not admit.
Okay. Kasi di ba ang data natin, meron tayong variable na, ito yung mga given, no? May variable tayo na admit. So 0 or 1. 0, hindi siya na-admit.
Yes sir.
1, na-admit siya. So ang ginawa natin, predict natin based on GPA and rank kung ma-admit yung student or not. So nag-logistic regression tayo. Okay, and based on the model, ito yung nangyari, no? Yung model natin, 208, no? Sinabi niya, will not be admitted. Wait, ha? Ito yung predict natin, ano? Ito. 208 dun sa predict na hindi ma-admit. Okay? We're actually not admitted. So tama
Yes,
ito. Diba?
Yes sir.
Yung ba yung tanong mo, yung ibig sabihin ito?
Yung question ko sir is
Sige.
oo. Pero sir nasagot niyo po yung question. Yung question ko was yung if we are creating a model, example dun sa data natin if it's to admit or not to admit. Yung assumption ko ba dun sir, pwede kong interpret yung model natin na it's a model to determine if to admit as well as if not to admit or
Yes.
isa lang doon.
Hindi, kasi corollary yun di ba? Binary siya, so kung ma-admit siya, ibig sabihin, false yung hindi siya ma-admit. Gets mo? Kunyari, may based on the GPA and the rank ng school, i-run mo sa model yon, i-run mo sa model natin yon, then mapipredict natin kung yung estudyante na nag-apply will be admitted or not.
Okay.
Same din sa sinasabi mo kanina, no? Let's say you're given parameters. Kunyari, example, so isang company maglo-loan, no? So let's say ang mga parameters na dapat tinitingnan diyan, debt ratio, total assets, let's see ano ba? Quick ratio, whatever, no? ROE. Let's say these are the variables that we're going to use in order to predict whether this company will default or not.
Opo.
Pasok ng isang company, mag-loan. So, due diligence, no? Kinuha natin yung ROE ng company na yun. And then we can use the model in order to determine, to predict whether that this company will default on its loan or not based on the model. So quantitative yung model natin. But of course, guys, in reality, meron ding qualitative, no? Kasi kunyari, yung presidente ng company na manghihiram, kaibigan yung CEO ng bangko. You get yung, of course, this might be exaggerated, no? So, malaki yung kapit niya. So, may mga qualitative factors na gano'n na ipapaloan pa rin siya kahit na yung based on the model natin, magdi-default yung company na yun. But strictly speaking lang, based on the model, kung yun lang talaga yung titingnan without any qualitative factors or additional factors to be considered, the model will give us a prediction whether that company will default or not. And let's say, and we are 72% confident dun sa ano natin, sa model natin.
Okay, sir. Yung related question dun, sir. Sir, okay lang baba tayo dun sa line, line 201.
201, okay?
Yes, sir. Yung ibig sabihin, sir, ng 27%, yan yung correct na...
Hindi.
Sorry,
ano natin, yung maling prediction.
Kasi sir, based dun sa table dun sa kanina, ang tinitingnan ko, sir, is if not admitted, tapos ano yung correct naman nung side na yun, which is yun ba yung 27%?
Yung 27% is 15 plus 73 divided by the total.
Okay.
Divided by
Kasi, sir,
325. So tingnan natin ha. So that's 73 plus 15. Yun ang maling ano maling predictions eh. 73 plus 15, no? Divided by ilan lahat yung train data set natin? 325. Train to train. Hindi siya yung hindi siya yung, di ba?
400
Inisip na
yung
natin to?
total. Apo.
Hindi, 325 yung total natin. Kasi we're just using the train data set. No?
Okay, sir.
Okay,
Yes.
yan. Yan, 27%.
Okay.
Ito yung maling natin, maling prediction. So doon sa predict niya na hindi matatanggap, no? 208 lang yung tama. 73 mali. Okay, so if you take a look at yung correct na prediction niya doon sa hindi ma-admit, 208 lang yung tama niya divided by 208 plus 73. 208 plus 73 is the total of the predictions na hindi ma-admit, no? 208 doon tama. So yung tamang tamang prediction as far as hindi ma-admit is 74%.
Okay, sir. Sir. Ganito pala yung question ko, sir. Yung other side naman, sir, yung kunwari yung 29 over 29 plus 15. Kunwari, sir, mas mababa yun kaysa dito sa 74%. Ano dun yung titignan ko, sir? Na parang assessment if the model is good or bad.
Well, unang-una overall, no? Kasi yung model kasi natin, it's an overall, binary kasi siya. It's an overall model, no? So hindi mo lang naman tinitingnan yung yung predictability ng ng tamang prediction mo. Although may ganun sensitivity at saka sa machine learning, maggagawa din tayo machine learning. In fact, yung susunod nga sana machine learning, may sensitivity at saka may isang measure. Ang tinitingnan yung ilang percent yung tamang positive. No?
Okay, sir.
So may mga ganung dimension. Okay, so hindi lang overall, but you can also have yung tamang negative tsaka yung tamang positive. May ganung dimension. Okay, but that's actually more of the province of machine learning, which we're going to look magkaka-example tayo. Yung susunod nga sana, pero I don't think that abutin natin siya ngayon. No? Okay, so tingnan naman natin guys ito. Tingnan natin to. What's this? So we now have our model for the training data. Now, i-test natin yung model natin if okay siya sa testing data. No? Kaya nga natin pinapartition yan kasi gusto natin ma-model din yan based on an unobserved data. Ibig sabihin, hindi pa nakikita ng model natin yung mga yung observations na to. Okay, so here we're creating an object called P2. Okay, so predict na naman natin to based on the model, and then we're going now to use the data, testing data. And then type is equal to response. Ano to guys? This is your probabilities, di ba? Ito. And then again, another object, pred2. If else, your P2, which is this one, which is your vector of probabilities, if it's greater than 0.5, then give it a value 1, otherwise 0. And then compare natin guys yung first 10. Let's see. Okay. So ito dapat, sorry para mas lang. Okay na. So test and then admit lang. Para hindi na ibigay yung buo. Run. Alright. So ito guys yung natin, yung model natin, no? 001, 0000. Ito yung actual. 0, 0, 0, tama. 1, tama. Tapos ito mali, no? Mali, tama, mali, no? Okay, so when we run the model using the testing data, Okay, ito yung mga comparison. And then, compute natin, just like what we did a while ago. Okay, ganun din, mag-create tayo ng table comparing yung predicted to and then the actual using the test. Test. Ang kino-compare natin dito yung test dataset. And then, i-print natin yung table na yon and then get the percentage. Okay, so this is now the result of the model for testing. Ang tama natin 48 at saka 5, ang mali natin yung 20 at saka 2. Around 71% as compared to 72% dun sa training data. So, not bad, guys. Not bad. Ibig sabihin yung model natin was able to predict correctly 71% ng bagong data na na pinasok natin. Okay? 29% yung kanina around 28%. So not bad. It's a good model, guys. Malapit siya. Kahit na hindi pa niya nakikita yung testing data, ngayon lang natin rinan. It was able to almost as equally as correct yung sa training data natin. Okay, pause muna ako. Any questions, guys?
None, sir, so far.
Okay, clear, no? So ito, guys, yung advantage ng natin ng yung training at saka testing. Experiment to guys, subukan yung i-run, no? Using yung lahat ng 400. Okay, possible that mas mataas yung yung correct, no? Yung correct. Kaso, we don't know what will happen if we kunyari may at saka yung availability ng data. Paano kung wala ka ng idadagdag na data? Paano natin malalaman kung okay yung model natin? Iginamit na natin lahat yung sample natin dun in preparing that model. So which we call overfitting. Okay? Sige. So what comes after this? Okay. Let's go back here, guys. So ma-explain ko sa inyo ito. Just some more discussions about yung log odds, yung odds at saka yung probabilities, no? So just by way of quick review, no? Quick review lang. Okay, so yung log odds natin, di ba yung log of P over 1 minus P. Tapos yung odds ratio natin will be, log odds natin will be log of P over 1 minus P. Yung odds natin, natanggal na yung log nito. Kaya P over 1 minus P lang. And then yung probability natin is this one. Okay? Yung e to the y over 1 plus e to the y, or exponential ng log odds, kasi yung y natin yung log odds over 1 plus log odds. Kaya ang gagawin natin in the next part, i-compare natin yung relationship nitong log odds at saka ng probability. Especially itong log odds at saka probability kasi may may figure yan na pinapakita. I don't know if you're familiar with the sigmoid. Have you heard of the sigmoid, yung shape na yun? If not, papakita ko roughly dito kasi yung data natin maliit lang 325 lang. So hindi siya masyadong apparent. Pero let's go here, guys. So ito. Okay. Di ba alam natin yung P1 natin, if you recall, guys, this, negative 0.933, that's your log odds, di ba? Kanina in-explain ko to. So I'm just going to call it log odds, yung P1. And then how do you get the odds ratio? Just by getting the exponential, e to the log odds, no? Yun yung natin. Yun yung odds ratio natin. And then the probability natin, yung probabilities natin will be ito, di ba? E to the log odds over 1 plus e to the log odds. Okay? So we can run this, guys. Run natin to. Run. Okay, so si log odds, guys, let's check log odds kung siya ba yung log odds natin kanina ito, no? Yun na lang natin. view log odds okay, di ba? Ito yun, no? Di ba? Negative 9.933. Alam natin na log odds yan, guys, kasi walang negative sa probability. No? And then i-view din natin si odds ratio. Yung E to D, ano to? No? Okay, if you take a look at this, guys, yan nyo minimum ng odds. Okay. Ang odds ratio, guys, walang negative. No? Yung log odds lang yung may negative. Okay, and lastly, yung probabilities view ng prob. Okay, ito yan, diba? 0.28, 0.29, 0.68, ito yan. So we now have three objects, log odds, odds, at saka probability. I just want to show you the relationship between them. Okay, so here, by the way, guys, yung odds ratio, another way to compute for that is based on the log odds, Q, no? Q log is, no? Yung probability naman P log is ng log odds. Just to inform you about it, no? Ito kasi ang ginawa natin dito, finormula talaga natin exponential at saka exponential ng log odds ratio. Okay. So let's create an object called D, data frame, and then pagsasama-sama natin si log odds, si odds, at saka si probability. And then let's get the first four values of that object D. Yan. So pinagsama-sama natin dito, guys, si log odds, si odds, at saka si probability. Okay, so i-plot natin. Yes. Nag-GG plot ba tayo dati, guys, sa first few sessions? Nag-example ba tayo nito? Yung GG plot 2?
Yes, sir. Yes,
Yes.
sir.
Okay, so I'm sure na-install nyo na yan, ano? So library natin, tapos i-GG plot natin yung object, yung data na D. Ang lagyan natin sa x-axis natin yung log odds, yung sa y, yung odds ratio. And then maglalagay tayo ng geom line. And then lalagyan natin ng continuous, yung sa scale, from negative 3 to 3 by 1. 1, 2, 3, 4, 5, 6. From negative 3 up to 3 by 1. And then lagyan natin ng title, odds versus log odds ratio. Let's run this. Okay. So this is how a log odds ratio will look like. Kung medyo malaki-laki yung data set natin, no? Kasi 325 lang, it will actually look like more, parang paganto siya, guys, parang pagano'n. It will approximate this one, tapos bigla siyang tataas dito. Dito. Okay, so hindi na masyadong apparent dito kasi yung sample size natin 325 lang. But this is the shape of the log odds versus the odds ratio. Okay, take note, si log odds lang may negative, di ba? Okay, linagay ko negative 3 dito kasi ang pinakamalaking negative, minimum ng log odds. Minimum niya is around negative 2.88. Kaya linagay ko from negative 3 yung x-axis natin. Okay, clear, guys? Clear? So this is how your log odds versus log odds plot will look like. Okay, clear, guys? Parang horizontal line, tapos biglang aangat siya. Which means, guys, that habang as your log odds increases, your odds increases. Okay, so si odds, guys, walang negative value siya. No negative value. Si log odds lang yung meron. Okay, next. Okay, let's now plot the probability and the odds. Pareho lang from the object D. let's put on the x-axis yung odds ratio and then on the y-axis yung probability. Ito guys, parang mirror image to ng ano, ng yung kanina. No? It's like a mirror image. Plot natin. Okay, magkano siya? Ang tagal na naman mag-run. Nag-plot na sa inyo?
Yes, sir.
Okay, how does it look like, guys?
Parang concave na
Inverse siya ng ano, di ba? Ng log odds at saka odds ratio ng plot. Di ba? Yan. Okay. Inverse siya, no? Yung isa pa ganito, ito siya pa ganito. Okay, now, yung last, ito guys, yung ano, this is now the plot of your log odds and your probability. Okay? So, geom line siya. Tapos nagpalagay ako ng horizontal line, okay, nadadaan sa 0.05. Okay, dashed line siya. Tapos vertical line din, okay, ang x-intercept niya, it means it will touch the x-axis at 0. Okay, may gray siya, tapos dashed line din siya. And then yung sa x-axis, from -5 to 5, increments of 1. And then ang title natin, probability versus log odds ratio. Let's run this. Okay. Hindi siya masyadong apparent dito guys. But I'll give it another example. Okay, hindi siya masyadong ano, pero this is actually the sigmoid. This is actually a sigmoid. Hindi siya masyadong ano dito because of our limited na sample natin, no? But here I gave an example. Okay. So as an aside to guys para makita niyo yung that's why guys hindi magandang ano linear model yung ano yung logistic. Okay? So dito so I created another log odds. It's a sequence from -5 to 5 increment by 0.1. Okay? So ibig sabihin -5, -4.9, -4, -4.8, etc. So yun ang log odds natin. Take note, may negative, no? Si odds ratio naman, so kukunin lang niya yung exponential nitong log odds. Tapos si probability, ginamit ko yung p log is na function. Okay, so these three guys will create yung log odds na values, odds at saka yung probability. Pareho sa taas, but iba yung mga values na to, no? And then nag-create ako ng object na D1, data frame ulit na pinagsama ko si log odds, si odds at saka si probability. So i-run natin tong first 4. Yan. Okay, and then type natin si head D1. Okay, so ito yung D1 natin, no? Okay, log odds from -5 increment by 0.1, -5, -4.9, and then yung odds ratio, okay? Odds ratio, and then yung probability. Okay, dito ipa-plot ko lang guys yung ano. I'll just plot the probability and the log odds ratio. Yan, ito. Pareho din to sa kanina, no? Exactly the same. Ang object natin yung D1, okay? Log odds 1 and then probability 1, okay? Ganun din, horizontal line, may intercept sa 0.5, etc. So if I run this guys, Control Enter. Okay, so mas mukhang ano na to. Okay, this looks like more a sigmoid. Okay? So yung ibang sigmoid nga mas ano pa mas ano. Okay, that's why guys it doesn't make sense to use linear model. Okay? Kasi kung mag-LM tayo guys, mas magiging prone to error yung ano natin, yung prediction. No? So that's why ang ginagamit sa prediction talaga is the generalized linear model. Okay, now may ano lang ako dito, may konting notes. Okay. We will not reach up to guys 9 o'clock kasi hindi naman tayo nag-break. Tsaka alam kong medyo heavy to sa ano, no? Heavy sa minds natin. But let me just show you this very quickly. Okay. Ito, how to determine the cutoff. Although medyo nagkakamali ako dito, no? Chine-check ko pa mukhang may error ako dito. Kasi yung cutoff natin guys, di ba yung 50%? Is it always 50% yung cutoff ng whether to admit or not to admit? Or magdi-default ba o hindi magdi-default? Actually hindi guys. There's a way, no, in order to determine kung ano yung cutoff which will improve the probability of correctly predicting the success and the failure. So may way yan. And may I invite you to please install yung PROC. Itong ROC yung sinasabi ko sa inyo, no? Yung Receiver Operating Characteristics. Okay, and AUC, Under the Curve Receiver Operating Characteristics. We don't have time to really go into this, but I would receiver operating characteristics. Hindi ko alam kung saan nagaling yung pangalan na yan kasi matagal na yung pangalan na yan. Pero nakakalito nga yung pangalan kasi parang hindi naman siya related dun sa concept ng yung curve, no? But I encourage you to read on that, yung ROC, kasi ginagamit yan sa operations, kahit sa ibang ano ng finance. No? Okay, so install nyo guys and then i-require natin. Na-install ko na siya, kaya hindi ko na siya i-install. I-require ko na lang siya. Okay. Pakisabi sa akin guys kung na-install nyo na.
Yes, sir.
Yes, sir.
Thank you. All right. Now, gagamitin natin yung function niya. Okay, tingnan muna natin. PROC. What is this package all about? Sa PROC package, ang gagamitin natin yung maraming functionalities to. Yung isa yung ROC. Okay, yeah. Just to give us an idea, what wala. So packages na lang natin po. ROC. ROC. And PROC there. Display and analyze ROC graphs. So this is a package that's used. May mga information dito, wala masyado. Display and analyze ROC graphs. Yung latest update niya, bago lang, recently lang. September 2021. Okay. Tools for visualizing, smoothing, comparing receiver operating characteristics ROC curves. Okay. Ito yung sinasabi ko guys, usually tinatawag doon na AUC ROC. Area under the curve receiver operating characteristics. Okay? So may gamit din yan dito sa logistic regression. Okay, anong gamit niya? Sa logistic regression, guys, it will help us determine kung ano yung cutoff. Should it be 0.5, no? When I was doing this a few weeks ago, may na-notice ako na medyo hindi lang tumatama dito yung ano ko, yung model natin dito. So I'm sorry kung hindi ko pa siya natama, no? But I will try to see kung saan ako nagkamali dito. So gagamitin natin si ROC, guys. ROC. What's ROC? Okay, this is from the PROC. This is the main function of the PROC package. It builds an ROC curve and returns an ROC object. Okay? So gagamitin natin, guys, si ROC para malaman yung cutoff. And the function is, okay, so gagamitin natin yung, bibigay natin yung admit yung actual values, yung response variable natin. And then yung predictor natin, predictor is yung mod natin, yung model natin, and then yung fitted values niya. Okay, ito yung predictor natin. Ito yung ano natin guys, yung mga probabilities, no? Versus yung actual. Okay, so actual versus the probabilities. Di ba? I told you a while ago that yung mga ano natin, yung either ito, yung fitted values, or yung P1A natin. Pwede rin natin gamitin. But I just use this, guys. So, i-compute natin, i-ano natin yung cutoff. Okay. So, we now have this object called cutoff. Tingnan natin kung ano yung cutoff na yan. What's inside cutoff? It's a list. Ayan, guys. No? Sensitivities, specificities, and threshold. Okay? Ito yung tinatanong ni Richard kanina, yung ang basis ba laging yung ano, yung overall. Hindi, no? So there's such a concept called specificity and sensitivity. Okay, doon papasok yung tamang failure na predicted at saka yung tamang success na predict. But let's not go there now. Tingnan natin yung generic na ginagawa nito. Okay. So hahanapin natin guys yung threshold na magmi-minimize ng error. Okay, so let me see first. Tingnan muna natin guys yung names ng cutoff natin. Cut. Ito ginamit natin ng word. Cut underscore off. So what's inside this object? Yan, no? So, ito yung mga laman nitong may sensitivities, may specificities. Now, I would encourage you guys to understand what sensitivity, what specificity. Kasi pag mag-machine learning tayo, example, makikita din natin to. What yung thresholds. Okay, so, but I'll not describe that now. Okay. So, ito guys, I created this object called E. And then, pinagsasama ko yung thresholds. Sige, ano lang natin, no? I-cut off. Let's see what's inside dollar. What's inside, yan. Ano itong percent? Okay, hindi yan. Cut off. Let's see ano yung may mga laman dito. Sensitivities. What are the sensitivities? Okay. So mga percentage siya, no? So ang tanong, ano yan? Ano yan? So, but we don't have time now to discuss that. And then merong cut off. Dollar. Okay, mga specificities, tas mga thresholds, etc. Okay, so thresholds ito din. So these values mean something. They mean something. Okay, so it's I'll leave you guys to read on that. Ano yung difference in sensitivity, specificity, at saka yung threshold. Okay, and then we're going to create, hanapin natin. So may ina ba tayo dito? Naran na ba natin to? Okay, papahanapin natin guys yung, ito kasi yung error natin, ano? Okay, error natin, yung E. And then papahanapin natin guys yung best. Okay, yung best subset. Anong value guys ng cut-off which will give us the best cut-off. Okay, so hindi ko na muna guys i-discuss yung ano yan. Okay, and it turns out guys that the best cut-off is around 34%. Around 34%. And ito guys yung this plot, okay, pa-plot ko lang yung ROC natin. Okay, just to show you where this 33.6 came from. Yan. Okay. Ito guys yung lumalabas na na cut off natin. You notice guys, this plot tapos itong line na to, no? Okay. Saan ba dito yung pinakamataas na sensitivity at saka na ma-maximize yung sensitivity at saka ma-minimize yung specificity? Okay, so that's the goal here. Okay? The plot is between specificity and sensitivity, and it's called ROC plot. The best cutoff is the value of the curve that maximizes sensitivity and minimizes specificity. Okay, so my tool guy na ginagamit, no? My tools class na ginagamit in order to decide which cutoff, yung cutoff yung 0.5 kanina, no? Do we use? Okay, so it turns out here that the cutoff is 0.37. Okay, ito yun. Saan na siya? Okay, ito, no? 0.34 pala, 0.34. This is the plot. However, okay, hindi ko ma-prove to. So may somewhere here, guys, may mali ako. I haven't discovered kung ano yung mali ko, no? Somewhere here I'm having a mistake kasi so ito i-run ko lang to, no? This is just tells us that the best value of cutoff for classifier is 0.336. Ito, no? Yung best 0.336. Pero guys, pag ginamit natin siya, okay, gamitin natin siya, no? Gamitin natin siya for dali kasi let me see. Baka ma-discover ko dito yung mali ko. Ito yung cut-off ko, no? Train ang ginamit ko. Okay, sige. Susubukan ko, guys. Let me see. I'm going to run this sa train. Okay. Papalitan ko to. Pakipalitan nga, guys. Check natin. Train. Alright. So, we're going to generate another, gawin natin P2A. P2B na lang, guys. Kasi may P2A tayo kanina. P2B, and then, sorry. P2A pala. Kasi ito yung model using, gamitin natin type train. Okay. And then type is equal to response. Ito yung probabilities. And then if else, if P2A is greater than, papalitan natin to, 0.34. If it's greater than 0.34, make it 1. Otherwise, make it 0. So pinalitan natin, guys, yung 0.5 ng 0.34. Okay, so that's the use of the cutoff. Okay, so iraran ko to. So magkakaroon na tayo ngayon ng bagong vector ng ones or zeros, no? Okay. So dapat ginamit ko dito 2B, no? Kasi may 2A na tayo kanina. Okay, anyway. All right. And then let's see, guys. I-run natin to. Tab 2A, table ng predicted at saka yung actual. This time it should be train. Pakipalitan lang, guys. Train gamitin natin. Okay, tab 2A, tab 2A. Alright. Let's run. Okay. Yan. What do you notice, guys? Ito yung sinasabi ko sa yung nag-error ako. Bakit? Bakit ako nag-error, guys? Kasi kanina yung model natin, 72% yung di ba? 72% yung tamang prediction. Dito 64. And the ROC, that cutoff should be the should maximize yung natin, should improve our model. No? Kaso nagkakaroon ako ng error kasi yung kanina sa train 72% yung tama, 64 yung mali. Okay, so be that as it may, guys, I'll still look for kung saan ako nagkamali, no? But at least we know the steps, no? Ang importante dito, alam niyo kung paano ginagamit yung cutoff na yan. Okay, clear yan, guys? I'm sorry, hindi ko pa na ma-decipher kung bakit 0.64 yung kung bakit mas mababa pa, no? Kung 0.34 yung gagamitin natin. Kasi kunyari, what if we use 0.6? Kunyari 0.6 yung ginamit natin na cutoff. So pag 0.6 yung probability, gagawin yung 1, otherwise, okay. Right? So tapos i-run natin dito. Kung 0.6, guys, mas mababa. 70%. Sa 0.5, sa 0.5, 72%. So, ang tanong kasi, anong value ng cutoff ang dapat natin gagawin para yung prediction natin mas ma-optimize, no? Kasi kunyari 0.9. 0.9 ang probability gagawin mong 1. Otherwise, 0. So what will happen to our model kung tataasan natin yung benchmark? Okay, ito 68. Mas mababa pa rin. So the challenge here is, ano kaya ito, guys? What is this? So that ma-optimize, lalaki yung predictive power. And it's supposed to be this, yung ROC sana yan, which is this one. So baka nagkaroon ako ng problem sa pag-code ko dito. So I will still have to check, no? But that's how we do it, guys, no? Isa kanina 0.34, 0.34. Okay. Tingnan ko nga, guys, kung tatanggapin niya yung best underscore t. Okay. Kasi ano naman to no? Best t, para kung magbago yung best t, automatic dito mag-generate. Okay. Tatanggapin ba niya yung check natin. Yan. Okay. And then, natin dito. Tinanggap niya. Tinanggap niya. 65%. Okay, so any questions, guys, so far? I just have the last few minutes, guys, yung sa konting diagnostics, and then we're good to go. Imagine wala tayong break, guys, ha? So, tapos ano pa to? Applied regression. This is not an easy subject and masyadong technical siya, so it's really quite. Hindi, ako lang ba, guys, ako lang ba yung nakaka-feel na parang nakaka-drain din? Kayo, guys? Honestly.
Challenging, sir.
Hindi draining, ha? Hindi draining. Okay, nakakaano din kasi sa parang 3 hours tayo nag-iisip ng ganito. Okay, anyway, sige. So, yun, guys. So, if you can help me, guys, decipher kung saan ako nagkamali dyan, that will be good, no? Okay, diagnostic test, guys. Just like si multiple linear regression, may diagnostics din dito. So first, let's use the, again, itong object na to, package ito, library, survey, since na-install ko na yan. So paki-install na lang, guys, si survey. And then, tinan nyo na lang, guys, kung anong ginagawa ni survey. Nagkakaproblema yung mouse ko. Okay. Right, library. And then sa library, guys, gagamitin natin si regression term test. Okay, using our model. And then ito gagamitin natin, guys, per variable, no? GPA. And the measure is the walled statistic. Okay, pag rinan natin to, okay, here the p-value is 0.001. Parang individual t-test, no? So the null hypothesis here is that GPA is equal to 0. But we reject that null hypothesis, okay, by virtue of the p-value. Okay. Take note, hindi natin magagamit dito sa model. Nagbigay ako ng note dito, Dito, hindi. Nalagay ko ba dito yun? Okay, test of significance of predictors, GPA and rank. Note, GRE is not a predictor in the mod object. Pero let's try, guys. Tingnan natin dito sa sa unang model natin. Di ba yung unang model natin? Ay, napalitan na. Okay. Gawin natin itong mod X, guys. Mod X, yung unang-una natin. Yung kasama si GRE. Okay, run natin to. Di ba hindi significant si GRE, di ba? Okay, and i-try natin dito yan sa walled statistics. Try natin dito. Okay. I'll cross this out, and then I just copy this. Ito. Validate lang natin, Control C, Control V, and then i-test natin sa mod X, di ba? Mod X natin si GRE. Tingnan natin kung based on wall statistics, kung ano ba siya, kung significant siya. Run. Okay, 0.18, no? 0.18. So it confirms, guys, that GRE is not a significant predictor of dun sa model X natin. Hindi siya significant predictor ng admit. Okay, clear yan, guys? Clear?
Yes, sir.
Okay, and just a few more, guys. Ganun din si deviance statistic, no? And then it follows a chi-square. Okay, so ang tinetest nito, guys, similar lang sa din sa kanina sa wall test. Okay, tingnan natin na ANOVA. So mag-a-analysis of variance tayo ng model natin ng mod X. And then test natin is a chi-square test. Run natin to. Okay, so analysis of deviance table, binomial, logit, response variable natin, admit. Tapos dito, ito yung model natin. Okay. Alright, so ano yung lumalabas dito? Ano yung chi-square stat natin? Guys, ito, no? So si GPA, based on chi-square, significant siya. Pati si rank, significant. Based on the deviance measures. So the chi-square test on all the variables, GPA and the rank, are significant as the p-values are significant as the p-values are less than 0.05. All the predictors' contributions to the model are significant. Okay, and lastly, guys, yung R squared. Kasi di ba sa sa multiple linear regression may may R squared din. Dito din sa meron din, no? Kasi medyo mas mahirap i-interpret, no? So we have what we call a pseudo R squared, where we get the ratio of the D null, D fitted, and D null. Okay? Ang minimeasure dyan yung deviance. Yung deviance parang ano siya yung error din, no? Of the null hypothesis and the fitted model. Yung null hypothesis, guys, wala tayong predictors na gagamitin, no? Wala tayong predictors na gagamitin. So kukunin mo na yung average ni admit. Okay, the higher the value of this measure, the better the explaining power. So we're going to use from the library PSCL, and then ito yung function na gagamitin natin. So install nyo muna to, guys. Okay, ang ibig sabihin, this is from university to, no? And political science something, no? Check natin, ha? PSCL. Political science yung kasi ginagamit na sa political science, and then I forgot the name of CL. No documentation. Wala ko nga dito, packages. PSCL. Yan. Ayun, yan. Political Science Computational Library. This was developed by Stanford University. Okay, Stanford University itong package na to. So ginagamit siya sa social sciences, no? So ano bang ginagawa niyan? Okay, so wala siyang masyadong description. Ayan. Bayesian analysis of item response theory. So kasi 'di ba sa maraming sa political science o social sciences, experimental yung nila, yung mga research, no? And logistic regression plays a very important role sa kanila. So i-run lang natin to. Okay. So you'll notice, guys, na maraming measure ng pseudo, yung fake R squared. Okay, meron si McFadden, meron ito yung kasi ang ginagamit dito, guys, na sa pseudo R squared is maximum likelihood na method. So R squared, the maximum likelihood. And then this is another method. Okay, so medyo magkakalapit lang sila, no? 8%, isa 9%, so 13.4%. So this is the R squared. Medyo mababa yung R squared. Ibig sabihin, yung explanatory power niya is not that high. What could be recommended? Other variables should be included in order to predict kung maa-admit o hindi. And nakita din natin guys yung predictive power based on the confusion matrix. Okay, so let me stop our recording.